This video we're going to work on another polar integration problem. So we have the double integral over r of negative y squared dA. Okay, well r is the region in Q1, that's quadrant 1, bound by this. Okay, this is, by past problems, we know that is a circle. I'm just shifted over. I like to look at it this way. X squared plus y squared is r squared, and then for r cosine, I'm replacing x. Then I divide both sides by r, and I get r equals 4 cosine theta. And I don't know if you know from trig. I teach trig 3 times a year practically. But I know that's a circle shifted, okay, because it's cosine, it's shifted in the x, because it's a positive 4, it's to the right. So it goes to the right, and then the 4 tells me the diameter. I think that's a lot easier than the other alternative, is you had to complete the square of that original problem to see it. This also tells me my bound for r. Now I can see, because r, if you look, r changes. Right, that r is different than this r. It's longer, right? And as we get closer, it gets shorter. So that tells me that r is actually between 0, because we're starting in the point, right? There's the r starting at the origin. So r goes from 0 to 4 cosine theta. Right? We could just see that by converting the equation to that. That also helped me graph it, because the graph, and maybe it's because I teach trig so much, but I remember my polar equations that is a circle shifted to the right with a diameter of 4. So I have that. The only other weird thing is, okay, we have r, we need theta, and we can see how it's spinning. It's like going from, it's got to start here. You can see my blue line, and it's got to go all the way up. So I got to know where that angle is for my dark blue line. Well, I can use tangent. Okay, remember tangent theta is y over x, and this is kind of weird, but I can see what y over x is going to be from my equation here. If I divide both sides by x, I get y over x equals 1 over 2. That's what that line is equal to, and that's what I need. So the tangent theta is equal to 1 over 2. Tangent is, if you haven't put that together, tangent is directly related to slope. The slope of a line would be the tangent of that line. All right, so that means theta then, because it's not a pretty value, 1/2's not on my unit circle. So this is the arctan of 1/2. Right? I know that is the smaller one, so I know that that is going to be my lower bound, because that's where it starts rotating, right? Here. And we just found that line there is the 1/2. And then it goes all the way up to pi over 2. All right, now we can set that up. I'm going to shrink this and move it so I don't have to scroll so much. I have my bounds, so I can set this up. That double integral over r of negative y squared dA is equal to, okay, theta runs from arctan of 1/2 up to pi over 2. R runs from 0 to 4 cosine theta. And then the inside, we got negative y squared, so we got to convert that. That's going to be negative r sine theta squared. And then we got to switch to polar, so we got to introduce r dr d theta. So there's my integral. We can multiply that out and work it, so let's do that. I'm going to take us to one step, and then we'll use a calculator. This requires a reduction formula if you're interested in doing it by hand. The reduction formula is, it deals with sine squared theta is equal to 1/2, and then I believe it's a minus cosine 2 theta. You're going to want to check that, because one of them is 1 and one is the other. Here, I can just look it up real quick. Reduction formula for sine squared. I just forget which one's plus, which one's minus. I was right. Okay, so that's minus, and then if you have a cosine squared, you get 1/2 times 1 plus cosine 2 theta. If you want to do this by hand, you're going to use those in a bit. All right, so I'm still writing my integral there, and I'm going to go ahead and multiply that out. Okay, r equals 0 to r equals 4 cosine theta, and I'm going to get negative r cubed sine squared theta. That's just multiplying the square out, multiplying with that r, dr d theta. All right, we're going to do one integral, and then we'll let the calculator do it. So I get theta from arctan to 1/2 up to theta pi over 2. And then I'm going to go ahead and integrate this. This is going to be negative 1 over 4 r to the 4th sine squared theta. And I'm running that from 0 to r cosine theta d theta. Right, I plug that in. And you can see where this is going to get nasty. The 0 is going to go out because the r is going to zero the whole thing out. So I'm going to get theta equals arctan to 1/2 up to pi over 2. And then I got to plug these in. Okay, one of those 4s is going to cancel with that 4th, so I'm going to get negative, and it's just going to be 4 to the 3rd, which is 64. So negative 64 cosine to the 4th theta sine squared theta. That square keeps us from doing a u sub, unfortunately. What I would probably do is change that to 1 minus cosine squared and then distribute and then work from there. But there are multiple ways to do this. This is d theta. I'm going to use a calculator at this point to save some time. I'll give you the exact answer and then I'll give you the approximate that the calculator would have given you. Okay, the exact answer, hold on, I'm on the wrong page. Here we go. The exact answer is negative 104 over 375 minus 2 pi plus 4 arctan of 1/2, right? If you used a calculator, though, and we just want the decimal, it's negative 4.7059. So it would have taken that reduction formula. It would probably take me another page of calculations, hence the reason I'm going to go ahead and stop there. You're more than welcome also to use a calculator at this point if you get some nasty stuff. I would also practice by hand because I can't promise that your DiffyQ instructor after me is going to let you use calculators for one-dimensional integrals. My guess is no, they're not going to, because that's all that really shows up in DiffyQ.